Hi, my name is Zachary Angelat, and I just wanted to go over uh, basically like a blog thing I wrote about the basics of a neural network. And I wrote this because when I was attempting to work on my own stuff and maybe trying to figure out more information or whatever, I think people didn't care or didn't react well or something. And I just felt, well, maybe it's either, you know, they're not really for neural networks or they're against it or whatever. I also would sometimes meet up with groups and would, some people would be anti AI or LLM or neural network or whatever. And I felt like as if uh, there was a weird pattern of behavior where people attempt to use like LLM and then automatically assume it should be used to like take over someone's job or something like that, which my reference frame is always it's just code. So I don't know why you would be afraid of just code. And so for me, I sort of thought it was weird. Like at a baseline, I thought it was weird. Um, so I decided, well, you know, maybe try and do something about that. Maybe try to inform people about that. Maybe if that situation comes up again, I can simply send them a few links and maybe they'll begin to understand that it's just some functions and data structures. It's that's it. I mean, it's like being afraid of Rust or something like that. I don't know. I don't get it, but sure. Um, Is it complicated? Does it complicate your code? Yes, yes, it does a lot. I don't think there's really too many ways around that. Maybe someone who comes along who is, knows the best way to do things and has a lifetime of experience in it can solidify it all into like a simple like regex function or something. I don't know. I'm not there yet, but until then, yes, yes, it will complicate your code. Um, I understand that's like the point of Go, but it's up to you, right? It's just another paradigm. Much like web servers can be just another paradigm and can complicate your code. I mean, any part of it could. So that's just on you. So I wrote this little blog article thing in order to um, run it down, sort of. Um, and like this kind of states, it's like a business. It very much is like it's so much like a business that I didn't even realize the business was that much like a business in a sense of you do have the CEO, you have the managers, you have the workers, and the CEO makes some kind of guess at the 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 business logic or some kind of prediction on maybe where the steering of the business should go, and it goes down the line as far as what happens. It's more like a neural network that runs forever, like an infinite loop, so to speak. And uh, it always starts off with kind of the CEO's guess or blame, or not blame, but CEO's guess or prediction. The next part is the actual blame part because you have to make the correction or know what correction to make, I should say. And the next part after that is the workers who nudge the values. And it sort of comes down to, although everything always gets more complicated, but we'll stick to the simple stuff for right now. With weights and biases, those would be the things you would nudge. And so as the loop runs, you make another prediction, you do more blame, and then you nudge the values. You just keep looping through that. That's generally what I explain here. Um, it's just I think it's good to go through to uh, get the vocabulary under you to be familiar with forward pass, backward pass, and weights and biases and all that. I just think that that's something that's really important. Another thing you can use Gemini with the learning, which I think is great. Um, I think it's great in the sense of you can ask it to teach you things, and you can also word things really well too. But the teaching you part makes you fill in the gaps, and so I didn't exactly add like guess the value in here because Gemini can make you do that a million times over in a billion variations instantly. So, you know, me adding one or two to fill up the gaps kind of doesn't make a whole lot of sense. so, so yeah, you start out with, I guess you could say, the initialization of the variables, and those would be the weights and biases. That's like, so you have to start out somewhere. You can't just do a random string and then hope to come out with a output of a neural network of some kind of guess of something that you had wanted to guess. It has to be some premise, right? And so that's sort of what this is. I mean, this ain't the initialization, right? But it's let me zoom in a bit. It's I mean, in effect, it's the guess, right? Because you have to fill these in. This isn't the initializing the variables, but it's you have to fill these in with something, and that something is the prediction, the guess, whatever what the CEO does. I like to use that term with the CEO and the manager and the worker just because it takes away from it being so mathy, right? As it gets more complex, that becomes a lot harder of an idea to hold together because you may have many of these. You may have many layers and you may have many ways to normalize data, and it becomes really complicated. But just for the sake of remembering the terms, this is a good portion of the neural network. You're attempting to get data, make a prediction, and put it all together. And these kind of stand for what they are. Weights, biases. It's very much part of a guess. I guess I should have put guess there, but whatever. And that is a big part of the forward pass in a sense. Um, so this would be like the end, or not end, but this would be the what you're trying to guess, right? You need some kind of problem, and what is this? Why is this there? Well, I don't know. You're in the bigger scheme of things, you're trying to guess the next word or whatever, right? Or I don't know. You're trying to sell a certain product, and maybe these are how you weight the value of those products or something like that. You guess bananas are 85 cents or something. Sure. But that's a prediction. You need to start somewhere. And this isn't necessarily this, but it's what can be used for that, right? Because you have to start somewhere with some kind of data. Maybe it is the input or whatever. The next part is the just the base of the guess itself, right? When you go, let's say you made your guess that bananas are 85 cents a pound, but you walk in the Target and you realize, uh-oh, they're selling for 50. You realized, hmm, something's gonna happen here. That's probably not gonna be good, right? That's your problem, right? You made a guess, you compared it to something that you kind of know as a gold standard, and you got a result. What do you do now? Right? You can't use this. You just know that your guess was kind of dumb, right? Uh, so with any neural network thing, what you have to have is some form of uh, filtering out noise. And why do you need to do this? So unless you're some kind of crazy math person, you're going to with neural networks you tend to deal with confidence levels. And that becomes extremely hard if your values are negative. I mean, unless you're one of those crazy math people who can do that. Uh, and there's a lot more of these like filtering functions that kind of put the magnifying glass on a certain part of the data. As things become more complex, you're gonna want to narrow down what's useful to you. And neural networks in general, you're gonna realize, you're gonna have to have structured data. You can't just feed it a book and get out a response that it's gonna make any sense. You have to nudge it toward, okay, this is the golden standard. Give me something like that, will you? And you may have fed it $100, but this is generally what you're going to be doing. It's kind of like going to class or something when you're little. You can memorize all the letters you want, but unless someone gives you a word, you ain't going to know what's going on or why. So this function basically just returns positive values. That's all it does. Um, Yada yada. And so this is like the end result of that, right? You made your guess, but you kind of realize this ain't good. This ain't gonna work out. Now what? Well, um, this is kind of putting it somewhat all together. So this is the guess. This is where you would use that function in order to make things positive, and then you would do the target. The how off were you, right? And this would be where uh, you need to find a way to, because you're dealing with confidence levels, so you need data in a format that's just a lot easier to crunch down and work with instead of just 333.3333. You're doing something to kind of smash it together, and and with this number you would times it by the learning rate minus the weights, and you kind of get this like nudged value. Um, why why do it kind of this way? Like I said, this is after you filtered it, you've smashed it together. This is your off guess, and you're doing a learning rate, like 0.1 or whatever it is, and you're minusing it from the weight. And then result is maybe some number that you did want or don't want or whatever, but you're gonna try and cycle through it to try and see if your end result after training is uh, good, or some kind of confidence level. Um, so so if you're gonna try and do this as a whole training thing, you're gonna need epochs, which is sort of like a big loop. It's a counter. And outside of that loop, you're going to be making a guess, or part of your guess is the initialized values, your learning rate, your real value, the correct answer. And when you begin to do that, um, like I said, this is the forward pass. You're making your guess. How off are we? The backward pass begins to do the blame, and that's basically kind of a smashed value of how much you really are off. And that learning rate is sort of a way to, what's a better explanation than that? You're incrementally trying to create new values so that when you do train or run it through the for loop, you're getting it more toward the target value, because it's fun finding Danny if you know the answer, but you may not. Let's say you're doing a sentence, you know, I like the fish, and you give a value to each one of those words, and you're predicting the word fish is important or something like that, or is the noun or whatever, and you run it through this. You make the prediction, you're off by a bit, whatever it is, and you put on a certain learning rate. You Let's say you want to put in as an input the sentence, I like horses. Well, if you can get it to predict that the word fish is important or more important or whatever it is, or I guess you could say bananas are worth 85 cents or whatever, or they're really worth 50. You can then run it through with another item or a sentence and get the same kind of nudging to get it close to that number so that the output is that word, or that product becomes more the value of that target. Because the whole point of this is to attempt some kind of intelligence, right? It might be, in this case, really linear, but and single valued, not really a matrix, but you're attempting to have something run through a bunch of stuff to kind of get the same result with something else, right? At least that's the hope. Um, and again, forward pass, backward pass, and the nudging. It's really all you got to remember. Um, so then I go into 2 layers, which really is all the same stuff, but there's extra weights and values, or weights and biases. Um, so like I said, same old line. You're trying to turn it positive from the guess, and then the final prediction. But you notice right here between these two, there's B1, B2, and there's, I should probably put weight one. But so the initialization of these weights and biases obviously is going to be different. And, this makes it a lot more complicated. But what are you trying to get at is eventually you're going to be working into matrices, and then not only matrices, but eventually you're going to be working into batch processing these matrices, because maybe a picture of a cat or whatever it is that you're doing is going to be a giant thing of data, and you're going to need a way to process through it. It does make things a lot more complicated, right? Because it's not so much in your head anymore. It's not just a one line equation. It's now you have all these guesses in different orders, and so on and so forth. And the way you should be thinking about it is, like I described in the article, is, let's say, let's get away from, well, no, we'll keep the CEO, manager, and worker nudging, but we'll kind of blend it into your bouncer, and you're looking at, you're verifying age and you're verifying style, because I don't know, it's a fancy club. And the one layer is like, all he does is look at age and style. Does his clothes match? Does his age match? No? Okay, you're out. Well, 2 layers lets the bouncer look at both, mix and match. So now, and that's a really simplified idea, but the idea being that he can do let's say leather shoes and 35. It's a special night, or I don't know, a women's night, or whatever it is. You're able to then take that one piece of data and use them together instead of just on and off, on and off. Um, so then, you find out how wrong you were, and um, you you basically have extra values that you're now dealing with. That is the blame. How much did you really get it wrong, and it's crammed together. And uh, this is kind of like that last function we made in a sense, but I guess you're just looking for zero values and above. Um, and then you're taking it and you're kind of massaging the data from the error, so to speak, and then nudging the values. So because you have more weights and biases, so now you need to nudge each weight and each bias, but it's it's the smashed down, filtered, all positive value that you got kind of wrong that you're now nudging. You're creating an equation to get these values out for the next epoch and everything. And this is sort of a um, altogether thing, just to give you an idea of what it would look like altogether. And again, you would need to initialize all these values. That's part of the guess. Um, the epoch stuff so that you can continually run through it and um, massage the data, make the guess, make it up, that we just went through. Um, and basically, the learning part is really what's going on here. I mean, this is getting new data with the learning rate, but this is telling you how much did I get it wrong after clearing out all the stuff, smashing it. Um, and I do provide full examples that you can actually like run and see the value of and all that. Um, I did make a part two, and I'm not totally done with that yet. It's it's getting there ish. It's not well written. I need to break it down further a bit. Um, but it gets more into more complex stuff. Um, and I need to word it in a way that I think maybe other people can finally grasp, because this is three layers now, as you can see. And it does get a little different. Not really, but it kind of does. But you do lose a little bit of your mental model of exactly what's going on. Because now you're mixing layers and stuff. And it's not to scare you, it's just to say, well, now you've gone from a bouncer that can check age and style, and then now you can check it together to, uh, you know, uh, somebody who, I don't know, drives a certain car or whatever it is that you're doing, that you're trying to mix data to get it to learn. And so the blame kind of keeps going. Um, and as you can see, the learning rate, which is, I just think of the learning rate as something where that's actually where the math comes in, to where you put some in, you get some out that's incrementally different. Um, and then, yeah, there's even another way to massage the data. And this one makes sure that everything's kind of between 0 and 1, because now you're dealing with stuff that, if you're dealing with that many weights and values, or weights and biases, you're going to want a way to narrow it down even further than just positive. Um, so this also does random uh, value picking, I guess you could say. so that um because the problem that kind of ensues is this part gets a little too good at what it does. It starts doing some crazy blaming, and the problem with that is you may come up with some crazy number because you're trying to get to the target value, and you may be doing it incrementally through the learning rate with all these different weights and biases, but maybe a lot of that data that comes together isn't really that useful to you. You know what I mean? And in some instances, because numbers can get kind of crazy, you'll get a nan, not a number. And so this function, including the other one, ensures that you don't get that nan. You don't get some crazy number. So it focuses the data back down even further. Um, if you could think about it as a day off for the workers. And so you're kind of doing a sampling of the data that's wrong. Or no, the sampling of the data to get it more close to the target, but the blaming that happens isn't some astronomical thing. Um, and I give an example and everything. So yeah, and then eventually I get into multiple outputs and matrices and all that. I'm still kind of working on. Um, and it gets a little more practical, but also gets a little more complicated. And what I meant by matrices is like these guys right here, and running a bunch of for loops. 'Cause then things start to get loopy, because you have to go through each thing. There's ways to deal with that. Ultimately, I think the better way to deal with that is probably through LLM. Just because you're going to be dealing with a lot of this, and then you're going to be dealing with, let's say you want that neural network to read through books, but books aren't structured data, right? It ain't a JSON, it's a book. Well, now you're going to have shapes that are only two of these, and then 50 of these, and three of these, and your equation ain't gonna work out, right? If you're just looping, just run these loops like that, it ain't gonna work. And that's why a lot of times I'll use LLM to, because you're not gonna just use that function for one thing. You're gonna want to use it for all different shapes and maybe for different stuff in the future. And so kind of creating a function that can read these out in different ways and ignore others because maybe the last shape isn't full or whatever it is I think useful. Um, but that's sort of what you're kind of getting into. You're in a sense you're losing some of your mental model, but you're getting into a little bit more complex data. But that complexity is the cost to get to reality, which is actual data, actually reading books, actually reading images. Think linearly reality isn't like that. That would be a ridiculous array. That array wouldn't make any sense, right? It'd be like a ton of these in all different forms. Just wouldn't make a lot of sense. So, uh, yeah. So I'll probably make another video on doing that. But I just wanted to go over this so that you can read the article, you can look over the material, you can maybe watch this video, and eventually get some concept that all it is a bunch of functions that run, and that's okay. It's not a bad thing. It ain't gonna take anyone's job. It ain't used for everything. Uh, you know, it's just some functions. But okay, yeah. If you need anything else, let me know. Yeah, just let me know if you have any questions. Okay, thank you.